let's go. Good morning, everybody. Good morning to every one of you. I'm here with our prehistoric tools for research. A lot of people don't know what a paper and pen is. It's old school tools, still works. So, we were in this consumer's utility. Oh, by the way, let me see. I need to adjust the camera. Our cameraman is off today, so I am the one who is doing all the work. I think that will give us a perfect, as it does. Look at my head in the middle of the space between the, you know what I'm saying, screen and end of the frame of the camera here. So I'm in the middle. That's it. All right. We were studying and we had problem with, because I got super confused with everything, especially the Bertrand model, I had the problem that I had to scroll all the way up and down, but my cognitive load didn't have enough space to remember all the equations. Therefore, we are gonna use papers and then write the equations here. Therefore, I will bring my tablet on. So in Bertrand, what's the story? Consumer says there is a contract. There's always a contract. Consumer says, for this price, I will buy this amount, this quantity of product. So there is this pricing function. And users say, okay, I will pick, like, gives them a menu. Users, firms say, I will choose this price, and then the quantity will be found. All right, Cornell, we are done with Cornell. I want them Bertrand. So Bertrand model, by the way, the utility function of a firm is the same. So this is beauty contest, Bertrand. And Bertrand so Qi of P I think we agreed on a lot of this stuff. Qi of P. I will keep one page for all the formulas, right? Yeah, it's probably here, the page. Formulas. Qi of P is omega plus R and action of the firms are the PIJs, PI and PJ. PJ minus pi over 2, which leads to r is r positive, s is 1, and t is 1/2. And what else? Ui of p is also pi minus theta I. Yeah, price minus cost times qi. Uppercase. Doesn't matter. So this is the best response. Qi of p is the best response. Best response. Well, shit. That Qi of p is not the best response. Alright. Yeah, best response is should be action. So best response should be pi, which we can have it from RST we have already. Is S omega, which is omega, R sigma AJ, which is RJ PJ, and plus T theta I, which is 1/2 theta I. So what is Qi of p is demand curve? That's just demand curve. And we have to be able to compute demand curve based on consumers utility. So pi best response Qi is the demand curve. Perfect. And then we have consumers utility, which I already did some computation about it. And we know, for example, alpha is minus 1/2. Corno, R is negative. I'm scrolling again to search and it's really annoying. Alright, fuck that. I'm gonna do it again. So that's it. Consumers utility, let's go back on this. UQ equals 1/2 AQ Q. Consumers utility, to be honest, depends on the amount of we should not write the consumer's utility right away based on the price. We should write it based on the quantity of the product they use. Makes sense. And then quantity depends on the price. Plus gamma. I remember gamma is W. Q. Where A is alpha on diagonal and beta of diagonal. 2 sigma qi squared plus beta iqj plus gamma qi and alpha a equals alpha alpha beta beta. Perfect. And strictly concave, or A is negative semi-definite if and only if alpha less than beta less than minus alpha over n minus 1, given vectors of good prices. P, the consumer wants to utilize V, I want to call it V of Q and P, is the net utility. Perfect. And then this implies the inverse demand function. All right, maximizing max V for the consumers will lead to 1/2 A plus gamma. Oh, it will be AQ plus gamma 1n minus P equals 0. P equals AQ plus gamma 1n. Well, this is the formula for inverse demand. Demand is Q omega plus this. Now we have the inverse formula. So then P minus gamma 1n equals AQ, and QIP, I want to keep the formula, so I'm gonna remove these computations. A minus 1 P minus gamma 1n. And remember what is and proposition D.7 also. Perfect. we did the Cornell. Let's go to Bertrand. And did I also add equivalence? I feel I added. What is alpha? What is beta? Cornell. Okay. For Cornell, we have alpha minus 1/2, beta is R, and gamma is omega. Bertrand. Ferms chooses pi star that. Alright, before that, I want to go A inverse will be A minus 1 will be alpha beta AB 1 over A minus B to the power n minus 1 A plus n minus 1 B determinant. Alright. Okay, so these are bullshit. On diagonal, it is alpha plus n minus 2 beta over alpha minus beta alpha plus n minus 1 beta, and off diagonal it is minus beta over alpha minus beta alpha plus n minus 1 beta. Well, we are getting to a scrolling mode again. I don't like that. Then I want to say P minus theta also production using 3, we find that the Q star, geez. Bro, I'm studying. Maximizes Pi minus theta IQi, where theta I is the marginal cost of production. We find that the vector Q star satisfies this. Hence the welfare of the firm is this. No, I'm in Cornell. Okay, it's Bertrand. In Bertrand competition, each firm I chooses Pi star that maximizes. Alright, firm max UI, which is Pi minus theta I times Qi of P which is on P, maximum PI, sorry. Which is the best response we already have. Why are you? That I already have. B's diagonal with coefficient equal can be expressed as a function of alpha and beta. Q is minus alpha prime P star minus C. This formula, where is this coming? Q, I want to use it here. Q is minus alpha prime, that's funny, P star, the whole vector by the way, minus C, which I should say theta. How did you compute this? I don't know. Alright, back to the game. So Q, we want to find the Q that gives us the demand curve. I want to find how they found this formula, which is minus alpha prime P star minus C. How do you find the Q that maximizes this? First of all, our action. They should choose the PI. If they are maximizing UI, that maximizes. Try to maximize UI. Alright, you know what I'm talking about. So UI is PI minus theta I times QI of P, which we said A minus 1, P minus gamma 1n, right? Pi minus theta I, A minus 1, gamma minus 1 gamma n. Now you want to maximize this, run from Pi. How is that possible, by the way? Oh, we should times it QI of P. Yeah, okay, so dimension is wrong. UI is PI minus theta I fuck, I don't want to look at my phone. That's it. Okay, we can say U equals P minus theta A minus 1 P minus gamma 1n, and UI equals yeah, I'm assuming vector the same shit, U and EI, which is the column I. Perfect. How is that possible? Oh, so I'm wrong again. Nope. Actually, that's true. No, it's not true. It is QI. QI is not. Okay. Okay. I don't care. Let's get the derivation. UI. We can ask ChatGPT too, but pi minus theta I, a minus 1, p minus gamma 1 n. By the way, it's not super difficult. It is pi minus theta I. A minus 1 is alpha prime beta prime, right? So, oh, times EI. What the fuck? EIT. So we want to get its ith column. Ith column is sigma on j pj minus omega or gamma plus times beta prime plus alpha prime pi pi plus alpha prime pi. We had a lot of meat last night. Pi minus gamma again. Does alpha prime and beta prime sum to 1? I don't know. So if I want to round pi, then we have EIT a minus 1 p minus gamma 1 n plus alpha prime pi minus theta I should be 0. Okay, that's good. And EIT a minus 1 p minus gamma n is QI. I agree. So then QI will be minus alpha prime pi star minus theta I. I mean, yeah. And then you can say Q is minus alpha prime pi minus theta I. Geez, wait, what are you doing? Here. La 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 la. La 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 la. This is Q. Where is it? Show me. Show it to me. No, give this one to me. Where is the comparing? Oh, comparing to example this. Okay. And then we have Bertrand. We find this Q minus C. I want to make it theta. And hence W is this. Now let's go why W is like this. W of the firm. W of the firm is, well, what is the utility of the firm? I need this thing. All right. Utility of the firm, P is actually we know it, Pi minus theta I Qi, which is minus alpha prime Pi star minus theta I squared, right? And well, that's easy. Then the welfare of the firms are like that. Let me also change these ones. Ex post utility of the consumer is this. WC was, what was it? Utility of minus 1/2 AQ star and Q star. This is for the core node. But not net. It is net. So let's add this formula as well. Q equals minus alpha prime P star minus theta WF equals minus alpha prime P star minus theta and consumers will be, I think it is V of Q and P. Well, actually, yeah, their payments to the firms stays in the utility. So it is V of Q and P is 1/2 AQ plus gamma n minus P and Q. What is 1/2 AQ plus gamma n? We know that AQ plus gamma 1 gamma n is P. So here we have 1. Okay. So I can say I like to write everything based on P. Okay. 1/2 AQ, I can say 1/2 P minus gamma 1n, and then this will end up being minus 1/2 P plus 1/2 gamma 1n, and Q, we have the formula A minus 1 P minus, see, do you see that help here? 1n, which will be Minus 1/2 p minus gamma 1n inner product with a minus 1 p minus gamma 1n gamma 1n. Is that true? P minus gamma 1n, b is a minus 1. That's true. Quadratic cost. Quadratic cost of production in both competition models. We can also add a common cost of production of the form over c squared qi squared to each firm's utility, where c is a positive, a common to all the firms. It implies this. And the consumer's exchange exposed utility is unchanged, which was the shed. But what if we add that? Then what will be our utility? Does it change our parameters? Well, we have UI. Definitely changes our parameters. If we look at the formulas for Cornell, UI of Q equals QI, PI of Q. PI of Q is omega plus R sigma J QJ minus QI over 2. That's QI/PI minus theta IQI minus, now you're saying CQI squared. Over 2. Maybe it's just changing by a scale of C. Well, I wish we did it from the beginning. Alright, I'm not gonna compute this part, but well, it changes everything. What are you talking about? Anyways, we want to maximize. I'm just worried about my RS and T. Does it change RS and T? Well, yeah, of course it changes RS and T. What are you talking about? Do I wanna compute it again? Do I wanna? I give it to ChatGPT. So either I don't want to compute it and do just code this one, which gives me maximize WF plus W, the other one. What is alpha beta for this problem with? The same alpha beta, right? Alpha is minus 1/2. Where is it, motherfucker? Beta is R. Well, R is negative for Corno, for motherfucking Bertrand. Gamma is omega. No, that's not true. Okay, we are gonna ChatGPT. ChatGPT and check. Okay, I wanna do the code. Anaconda. Python and Anaconda. So what is it? What is the utility? Let's consider Corno. Hopefully Corno does the job. That's it. So for Corno, we can say welfare total is WF, or maybe I even wanna add, welfare frames plus lambda, or what is left? Sigma is taken, rho is taken, tau is taken, lambda is taken, mu is taken, u is taken, mu is taken. I don't want to use xc or zeta, so give me something. Kappa, kappa, I like kappa. Kappa WC, and what is it? WF, maximize this expectation, which is minus alpha n sigma AI squared minus alpha over 2 n sigma AI squared plus kappa, sorry. Oh shoot. Does it change everything? TA Python. Let's go to the welfare. So we have hyperbolic and we have elliptic. Elliptic is coming from positive semi-definite. Where is hyperbolic is coming from? From writing down those equations. It's coming from, you know, you remember, right? It comes from these equations. From here. And now we need to change everything again. Write down all of them. So I'm gonna do the computation with the C added. I don't want to restart them.